Hey everyone, let me know if you can hear me real quick. I realized that I need to fix something real quick on my end so that we can go live and practice all these AP Calculus AB MCQs. Happy Friday, everyone. Hope everyone is having a great day. Hopefully we're all having some fun plans for the weekend, maybe some studying. Okay, as I mentioned, just give me 1 second. I need to go ahead and first, let's go ahead and just leave this. Okay. Again, just give me 1 second. Let me know if you guys can hear me just fine. If so, that is half the battle. Okay, I think now I got everything working. There we go. So sorry about that. It definitely took a little longer than expected. I wanted to just make sure that I had Zoom open on my end so that I can actually write on the screen using my iPad. Anyway, what's going on, everyone? Hope you're having a fabulous day, morning, or evening from wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and today we are going to review AP Calculus AB multiple choice questions. As many of you know, there is a big exam coming on May 8th for a lot of those AP math students, and there's a lot of review to do. So that's exactly what we're going to do today. We're going to go ahead and review AP Calculus AB multiple choice questions. Morgan, how are you? If you're just joining, please let me know where you're tuning in from. Where in the world are you holding your phone, watching me do some math problems and hanging out with a bunch of math nerds? So anyway, just as you know, there is 30 questions on here. I believe 2 questions in this 30 number packet do not have a correct solution. So I'm definitely going to skip those, and I wrote them down on my end. All right, so we're going to go ahead and get started. We're going to go with number 1. If you can read the screen, that's great. If not, let me know, and maybe I can zoom in on every question if I need to. But anyway, in the very beginning, it talks about a particle moving in a straight line so that its acceleration is given by that one equation there. A of t is equal to 4t, and they tell us that at time is equal to 0, the velocity is 4. So I'm just going to go ahead and put that v of 0 is equal to 4. And they want us, it looks like they want us to find the expression of the position function. So they tell us that the velocity is equal to 4. Oh, and then one more thing that they also tell us in here is that the position function is going to equal to 1 at that same time. So s of 0 is going to equal to 1. So how do we go about this? Well, we already know the acceleration function. We know a of t is equal to 4t. And so the velocity is just the integral of that. So when you set that up, you get 4t squared, and obviously you have your plus c, and this is where we use the initial condition that when t is equal to 0, y is equal to 4. So we're going to go ahead and set this equal to 4, and we're going to plug in 0 for our t, and that gives us that c is 4. So now this is our velocity function. 2t squared plus 4. And now we're going to go ahead and find our position function, and that is going to be the integral of this specific velocity function. So we're going to go ahead and take the integral, 2t squared plus 4 dt, and that's going to give us 2t cubed over 3 plus 4t plus c. But don't forget that the position is equal to 1 when t is equal to 0. So if we plug in 0 to all the t values, we're going to set this equal to 1, and we get 1 is equal to c. So now we have our c function. So our position function is 2/3 t cubed plus 4t and then plus 1. And if you can see that, whoops, wrong one. That is going to be A. There you go. Yeah, absolutely, I can put the test on here. So let me go ahead and do that now. That's actually a really good... If you guys can do that, let me go ahead and put that in the comments there. Oh, there you go. I believe I just posted... there you go. I just posted it. So that's the link to the PDF. Hopefully you guys can see it, or you can open it up if you're looking on your desktop. But anyway, let's go ahead and go to a question number 2. I'm going to go ahead and scroll down over here. And if you guys already feel like you know what the answer to this is going to be, go ahead and let me know in the comments. So it looks like we're given a slope field, and we need to find the differential equation that represents this particular slope field. Every time you have a slope field, I always suggest you pick a point either on the x-axis and on the y-axis. Let me kind of zoom in so that we can see this a little better. There you go. I think that's much better. Okay, and the reason why I'm looking at that is because let's go ahead and just observe. This isn't the best point, but we're going to look at 2, 0. Okay, when you have that slope, if you look at all those slope fields, it looks like there's a positive slope. If you were to plug in 2, 0 into the first option, you would get 2 over 0, which is undefined. That's not a positive slope, so we can immediately cancel that out. We go to part B, and we try the same thing, that when you plug in 2, 0, you get 2 times 0, and that's a slope of 0. But again, on that point, it looks like the slope is going to be positive, so we're going to avoid that. We go to the next one. When you plug in 2, 0 into this slope, you get 2 plus 0, and that's 2. That's promising. But then when you plug in D, that's also the same thing. That's going to be 2 minus 0, so that's 2. So it looks like our options are going to be C or D. So now we're going to pick a different point. Let's go ahead and pick a point. Let's choose something down here, for example, the one in blue. This coordinate is 0, negative 2. And if you look at the slope field, it looks like there's a negative slope. So when you plug it into C, when you plug in 0 and negative 2 into C, you're going to get 0 plus negative 2. So that's a slope of negative 2. It looks like that's going to be correct. Just to verify, let's go ahead and test it into D. And that's going to be 2, 0. We're going to plug in the 2 and the 0 on there. And that's going to be 2. Not 0, not 2, 0, 0, 2. So that's going to be 0, negative 2. When you plug it in, you get 0 minus negative 2, and that's a slope of 2. So immediately we can say that's not going to be it. It has to be C. Okay, a lot of the times it's just some guess and checking, especially when it comes to the multiple choice. All right, let's go ahead and move on to the next problem. And again, if you're seeing this and have an idea of what the answer is going to be, go ahead and just put it on the chat there. Okay, so we have a number 3. If you guys can see that on the screen, that's great. Let me know if you can't see it otherwise, and I'll zoom out. So we have the graph that's defined. The graph of the piecewise function f is there, so we need to evaluate this function here. Now, be very careful. This represents f of x. What they want us to find is this integral here. So that's the integral from 3 to 8, f prime of x dx. Now, before we start trying to find the area underneath the curve, that's not what they want. Because this function, or this graph, is a function of f. So if they want the value of this integral, we're going to use the first fundamental theorem of calculus, and that's just going to be f of 8 minus f of 3. Much easier than just finding areas. Now we just need to find f of 8. We go to our graph. F of 8 is right here. That's going to be 0. So down below, we're going to put 0 minus f of 3. F of 3 on the graph is equal to 2. So now we're going to do f0 minus 2, and that's going to be negative 2. Oh my goodness, my iPad's going a little crazy. Let me go ahead and just fix that real quick. Okay, there we go. I don't know what it's doing there. So 0 minus 2, and the answer is going to be negative 2. And the answer is going to be B. Nice. Turtle, yes. Good job. All right, let's go to the next problem. I'm going to go ahead and erase my work. A very simple problem where they just asking you to evaluate this integral. Again, if you already know or what you think the response is going to be or the answer is going to be, go ahead and let me know in the chat. The way we're going to start solving this is, well, there's only one value in the denominator, so I'm just going to go ahead and rewrite that. Let's go ahead and do x over x minus 1 over x dx. And if we simplify that, that's the integral from 1 to 5 of 1 minus 1 over x dx. And now we're just going to integrate this. So the integral of 1 is going to be x minus the integral of 1 over x is natural log of absolute value of x. I put 5 there. Let me go ahead and change that. There we go. And don't forget that we need to evaluate from 1 to 5. So now we're going to go ahead and plug in the 5. So we get 5 minus natural log of 5 minus, and then we're going to plug in the 1. So 1 minus natural log of 1. All right, let's go ahead and simplify this a little bit. The 5 can subtract to the 1. That's just going to be 4. And then we have minus natural log of 5. And the reason why I'm not worried about the natural log of 1, because that is equal to 0. So this is our simple answer, 4 minus natural log of 5. And the answer is B. Wisdom, yes, this live stream will be on YouTube. I am currently recording it, and after this session is over, I will put it on YouTube. You can also find all the other ones. I believe it was yesterday, we did an AP Calc free response, so that's something that you can look at as well. All right, let's go to number 5, guys. Man, I am thirsty today. It's been a hot day out here. Hope the weather's treating you well. All right, so let's go ahead and I think we can just solve this. We don't have to worry too much about it. Okay, we have a limit. There we go. So we have that limit here. And if you try direct substitution, you're going to have 2 natural log of 1 over e to the 1 minus 1. Now, this is important that why you should always use direct substitution, because check this out. On the top, we get 2 times natural log of 1. That's just 2 times 0 over e minus 1. That doesn't cancel out. So our answer is just 0 over e minus 1, which is going to equal to 0. So our answer is going to be C. Yeah, I agree. It's 2 over e. I don't know why it's saying 2 over e. But why is it 2 over e? Because natural log of 1 is 0. On the bottom, we don't get 0. I'm looking at the answer key, and my answer of 0 was incorrect. I'm getting A, 2 over e. But who in the chat can tell me why it's going to be 2 over e? Because I truly don't think it's going to be 2 over e. I think they're counting on everyone making or using L'Hopital's rule here. But if I use direct substitution, right away I get 0 over e minus 1. Yes, I will scroll down. Let me know if this is better, maybe like this. Hopefully that's better. Okay, awesome. Okay, we're going to review that next problem. So let's go ahead and go to number 6. I'm going to scroll down, and I think that might look a little better there. And then maybe what I can also do is I can draw, you're going to see a little shape here. All right, let's go to number 6. So we have a piecewise function, x plus 5, and then x squared plus 2x plus 3. And now they're asking that we need to find which statement is going to be true. Okay, so we have f is continuous and differentiable, f is continuous but not differentiable. And then now we have f is differentiable but not continuous, and then f is defined but neither continuous nor differentiable. Well, let's see. Let's just check for continuity. Okay, if you recall continuity, the function has to exist at -2, and then the limit has to exist. Okay, so we can easily say, okay, well, f of -2, if we were to plug it in, we're going to have to plug it into the second function because that's where it's defined at -2. And that's just going to be -2 squared plus 2 times -2. plus 3. And you can easily see that this is going to simplify to 4 minus 4 plus 3. So this is just going to be 3. Now, if we test the limit as x approaches negative 2 from the left side, that's plugging it into the top equation. So that's plugging it into the x plus 5. So if we were to do negative 2 plus 5, that's going to be 3. And then the limit as x approaches negative 2 from the right side, that's just plugging it into the bottom equation. We already know that's 3. So it looks like the limit from the left and the limit from the right is going to be the same thing. Therefore, the limit exists at 3. And the limit exists at 3. It's equal to where the function is defined. Therefore, we can say that this is continuous. So automatically, let's go ahead and remove the options where it says it is not continuous. So let's see. Sorry, my iPad's doing some crazy stuff there. I'm going to go back over here. There you go. So C says that it's not continuous. We're going to say that. Okay, D says it's neither continuous, so we're going to remove that. Now we just have option A and B. And now they're just talking about whether it's differentiable at x is equal to negative 2. So what we're going to do is go ahead and take the derivative of the top, which is going to be 1 for x is less than negative 2, and the derivative for the bottom, which is going to be 2x plus 2 for x is greater than or equal to negative 2. Now let's just check if it's differentiable. Plug in negative 2 to both the top and the bottom. For the top, the derivative at negative 2 is just 1. And for the bottom, the derivative at negative 2 is going to be 2 times negative 2 plus 2. You can see that this is going to be negative 2. So they're not the same thing. Therefore, it is not differentiable at that point. So then the answer, it is going to be B. The function is continuous, but not differentiable. And I'm looking at the answer key, and that is correct. All right, let's go to the next one. I can now erase, I believe, all my other stuff. Okay. Let's go ahead and clear that. Okay, perfect. So let's go to number 7. I'll just kind of leave that there. I don't think we need to. Oh, actually, number 7 was one of the ones that had a wrong answer for all of them. So we're going to skip that. There was 2 problems on this worksheet where the answer key was incorrect. Okay, let's go to number 8. Let me scroll down so everyone can kind of see it. We're trying to take this limit. A lot of people would immediately plug in 0 in for the h, and that's fine. But the problem with that is that you're going to get 0 over 0. And then you can go ahead and apply L'Hopital's rule and find the value of h. There's nothing wrong with that. But this is something that we should easily recognize. This looks very similar to the definition of the derivative, or the limit definition of the derivative. So if you recall, when you have this limit, it's equal to the derivative of f prime, or the derivative of f. And that f, I'm going to highlight it, is cosine of x squared. So all we have to do is take the derivative of cosine of x squared. So we're going to go ahead and take the derivative, and that's going to be negative sine of x squared times 2x. And that's going to simplify to negative 2x sine of x squared. And now our answer is going to be D. Okay, so now let's go to number 9. There you go. Again, if there's not enough space on the screen, let me know. I'll try to zoom in or something if I need to. So now they're asking for what value of x of the function, or for what value of x at which the maximum value y is equal to 4/3 x cubed minus 8x squared plus 15x occurs on the closed interval 0 to 4. So what we need to do is we need to find the maximum. How do we find the maximum? We're going to go ahead and take the derivative and set it equal to 0. We need to find those critical points. So this is my function. Y equals 4/3 x cubed minus 8x squared plus 15x. So we're going to take the derivative. And if you recall the power rule, this is just going to be 4x squared minus 16x plus 15. So we have to set this equal to 0. And we have to find those values. I'm going to go ahead and factor it using... I'm going to go ahead and factor this using that slip and slide method. So what I do is I multiply the 4 to the 15, and that gives me 60. So then I'm looking for 2 numbers that multiply to 60, add to negative 16. That's negative 10 and negative 6. But because I multiplied by 4, I'm going to divide by 4. Again, this is the method that I like to use in order to factor this. Some people have different ways, but you should definitely find your preferred method to factor these values out. because now what we get is 2x minus 5 and then 2x minus 3. And we get x is equal to 5 halves and x is equal to 3 halves. Ooh, two values that are on the same interval between 0 and 4. So we got to figure out which one of these is going to be the maximum. And the way we're going to do this is we could do a number line if you wanted to. There's no issue with that. But I'm just going to go ahead and take the second derivative and plug in the 5 halves and the 3 halves and see which one is going to give me a concavity of that's negative, because then that'll give me a maximum. So if I take the second derivative, I'm going to get 8x minus 16. And again, all I have to do is plug in 5 halves. So when I plug in 5 halves into my equation, I get 8 times 5 halves minus 16. And that's going to be, looks like 20 minus 16, so 4. That means the concavity at 5 halves is positive. Okay? So what that means is the curve, or it has a concavity that's positive, so it's concave up, so this is going to be a minimum. So therefore, we know that the maximum is going to occur at 3 halves. That's the only option. Of course, this is a multiple choice, so we don't have to justify any other answer. Yes, turtle nuggets, you can absolutely do the number line if you wanted to. I just prefer to do the second derivative test on that one. Can you solve higher level exams? Yeah, I can do that. I'm going to try to do the BC exam possibly on the weekend or next week before the test, obviously. Okay, I am posting some TikTok videos explaining some FRQs, so that'll be exciting. I am going to post them later today. This is a no calc section, yes. Ooh, this is a really interesting one. Okay, I want you guys to kind of read this and try to think what your answer is going to be, because this is something that even shows up on the FRQ. So they're saying at time is equal to 0, a reservoir begins filling with water. For t greater than 0 hours, the depth of the water in the reservoir is increasing at a rate of r of t. So r of t is equal to the rate the water level, rate of reservoir water. Okay, this is the rate. So they're asking, what is r prime of 2? What is r prime of 2? Now, this is the derivative of the r of t. And a lot of people, because they see a derivative, they think, oh, that's just the depth of the water is increasing at a rate of 4 inches. So a lot of people would immediately say that my answer is B, because that's just the depth, or like the rate at which the depth is, or the depth of water is increasing. Because when we think derivatives, we think increasing or decreasing. However, r of t is already the rate. So if you look at option C, then we say the rate of change of the depth of water, meaning r of t. This is exactly what r of t is representing. Is increasing, that's the next part, is increasing. That means that the derivative of r of t is greater than 0. It is positive. And that's exactly what C is defining. It is increasing at a rate of 4 inches at time 2 hours. So the answer for this one is going to be C. A lot of people would choose B, but it's actually C. Let me go ahead and erase all my work here. We are going to go to this next one, to number 11. Okay. Whoops, scrolling too fast here. Okay, number 11. So f prime of x is equal to 3x squared, and they're telling us that f of 2 is equal to 3. Find f of 1. This is a very interesting one. Immediately when you have one initial condition, f of 2 is equal to 3, and they want another value, we can use the net change. That's what they call it, but really it's just the integral from 2 to 1, or I guess I'm going to change it. I'm going to do 1 to 2 of the function 3x squared dx. And this is equal to f of 2 minus f of 1, because that is the definition or the first fundamental theorem of calculus. Now, we know f of 2 is going to equal to 3. So we can say that this integral 1 to 2 of 3x squared dx is equal to 3 minus f of 1, which is what we're trying to find. So now all we have to do is take the definite integral on the left side using the first fundamental theorem of calculus. So this is going to be x cubed from 1 to 2, and that's just going to be 2 cubed minus 2 to the power of 1. And if you do some basic math there, that's just 8 minus 2, so 6. So back to our problem, we're going to say that 6 is equal to 3 minus f of negative 1. And now we're going to go ahead and subtract. Wait, did I not do my work right there? Because none of these are going to be the answers. From 2 to the limit f of 2. Yes, turtle nuggets. I'm just looking at my work. I'm just trying to see if I set it up right. Because I'm getting 8 minus 2, which is 6. But none of these are the answers. F of 2 is 3 minus f of 1. So the interesting part about this, if I move the 3 to the other side, I get 6 minus 3. And then I get that 6 or 3 is equal to negative f of negative of 1. I'm sorry, not negative 1, it's just 1. That's not going to make a difference. So they're saying that negative 3 is equal to f of 1. Can you all check my math? Did I forget the 3? You accidentally did 2 after the integration. 1 to 2. 1 to 2. Not 2 on the first. Ah, there you go. Thank you, thank you, thank you, thank you. Yes, there you go. Oh my goodness. See, I'm trying to like read the chat at the same time, just making sure that everything's working on my end. Sometimes streaming this stuff can be super annoying, but yes, let me just fix that real quick. Thank you, chat. You guys are the best. Oh my goodness. I hate when this happens. So going back to this, it's still the same steps. Now it's just the algebra, the basic stuff. When you do the second fundamental theorem of calculus, you're plugging in 2 first. So that's going to be 2 cubed minus, and then you plug in the 1, which is just 1 cubed. So that's just 1. And so this, again, is equal to 3 minus f of 1. So if I simplify this a little bit, that's 8 minus 1 is equal to 3 minus f of 1. 7 is equal to 3 minus f of 1. So negative 4 is equal to negative f, or 4 is equal to f of 1. Negative f of 1. And then if I divide the negative to the other side, I get negative 4 is equal to f of 1. So obviously during the exam, I would have gotten my answer wrong, but I knew that something was going on, and that's why I was asking the chat. So you guys are the best. The best. You know, 1 to the power of 3. My brain was just already going, trying to finish this off. Thank you, thank you. Okay, so let's go to the next problem, number 12. Let's see, here we go. So the particle moves along the x-axis, so that's t is greater than or equal to 0. Its velocity is given by that function. Which of the following statements describes the motion of the particle at time t is equal to 1? Ooh, so this is good. Check this out. So we have A, B, and D, I think, are going to be the possible options. Okay. So they're talking about speeding up and slowing down. Okay, the first thing that I'm going to do, because we're talking about speeding up and slowing down, that's where we have to describe, or we have to compare the velocity and the acceleration. So if I find the velocity at 1, that gives me e to the 1 minus 1 minus 3 sine of 1 minus 1. Let's just simplify this. It's e to the 0 minus 3 times sine of 0. Sine of 0 is 0, so that whole thing cancels out. And then e of 0 is just 1. So we can immediately say that D is not an option. Why? Because the particle is not at rest. Otherwise, the velocity will be 0. And now we're going to go ahead and take, because they're talking about speeding up and slowing down, we need to go ahead and test the acceleration. Because right now we got the velocity at 1 is going to be 1, meaning that it's going to be a positive value. So we can say v of 1 is greater than 0. And then now we're going to go ahead and find the acceleration, which is just a derivative of this function. And that's going to be e to the t minus 1 times the derivative of t minus 1, which is just 1, minus 3 cosine of t minus 1 times the derivative of t minus 1, which is just 1. And now we're going to go ahead and plug in 1 into here. So we have e, whoops, just trying to go with blue, but obviously my colors went off there. E to the 1 minus 1 minus 3 cosine of 1 minus 1. I just kind of want to make sure I color code it so you guys see what I'm doing here. So In for the first term, e to the 0, that's just 1 minus 3 times cosine of 0. Remember, cosine of 0 is 1, so this is just 1 minus 3. So we get negative 2. So what happens? If I compare, the velocity is positive, the acceleration is negative, so we can say it is less than 0. And when that happens, when you have opposite signs, that means that the function is slowing down. Because if they were to have the same sign, then it will be speeding up. Yes, do I have a YouTube channel? Absolutely. So if you go to the link in my bio, my YouTube channel will be on there, and I post all the replays. So right now this is being recorded, and as soon as I'm done, I will post a replay for this so you guys can look at the problems. And of course, there's more material for you to look at. Paige, unfortunately, this is not a calculator portion, but if it was, you would just plug it into the calculator. I don't know what calculator you have. Hopefully it's like the TI-84, and from there you can take the derivative and plug in the value. But in this case, unfortunately, you just have to take the derivative. Okay, let's go ahead and go to the next problem. Number 13. Okay, so it seems like we're given the table above, and it gives us selected values, and it's a twice differentiable function of f. So which of the following intervals must there be a number c such that f prime of c is equal to negative 2? I'm hoping that you guys can immediately recognize the type of problem this is. Zach is talking about chain rule. I feel like we can maybe do chain rule. Andrew, shout out, man. Someone said IVT. IVT could be a problem, but notice that we're given the original function, and then we're looking for the derivative. Okay, someone said, can you zoom out? Let me know if I'm going to try to zoom out real quick. Let me know if that's better. I know it's a little difficult with this because, I mean, it's a document that has all kinds of stuff, but is that better? Okay. Okay, cool. As long as you guys can see now. That's the important part. Okay, cool. So again, what we're trying to find here is we're trying to find a value of c, or which interval is going to satisfy where there is a c value such that the derivative is negative 2. So people keep saying the IVT, someone said IVT originally, but this is going to be the mean value theorem. Why? Because we're given the original function. You'll see this is f of x, and we're trying to find a c value where the derivative is negative 2. So that's automatically when you talk about the original function, and then you're trying to find a value where the derivative is equal to another value, that's going to be the mean value theorem. And if you recall, the mean value theorem tells us that there is a c such that f prime of c is equal to f of b minus f of a over b minus a. Okay, so we need to find that interval. And I wouldn't say it's that difficult. Well, we already know that f prime of c has to be negative 2. So we need to find the interval where f of b minus f of a over b minus a is equal to negative 2. So let's just go ahead and test some values. Okay, we got time. So let's try 0, negative 2. So that's this interval here. So my a is going to be 0. My b is 2. So if we set this equation up, if we do negative 2 is equal to f of 2 minus f of 0, you're going to have 2 minus 0. Now f of 2 is going to be negative 1, given on the table, minus f of 0, which is 1 over 2. This is negative 2 over 2. That's equal to negative 1. That's not what we want. Okay, so now we're going to have to try another one. Let's try the different interval. Maybe perhaps 2, 4. Let me erase the work here. Again, maybe perhaps 2, 4. So my a is 2, my b is 4. So going back to this, f of 4 minus f of 2 over 4 minus 2. Well, let's see. On the table, we have negative 5 minus negative 1 all over 2. So we have negative 5 plus 1 over 2. Oh, negative 2. That's exactly what we wanted. So that means that on the interval 2 comma 4 is where MVT is satisfied. Aiden called it. B. Called it, guys. All right. Interesting problem that I truly enjoy. It's just a derivative. You know, we got to definitely get used to these derivatives. It's not that difficult. Obviously, you know, at this point, I mean, I'm pretty sure y'all are very familiar with your derivatives. So let's just go ahead and do the chain rule. Yes. So we're going to take the derivative first of tan. So that's secant squared times natural log of x. And using chain rule, we're now going to take the derivative of natural log of x, which is just going to be 1 over x. So we're looking for this solution. Secant squared of ln of x over x. What do you know? It is c. Chain rule. Chain rule right away. Okay, here we go. Number 15. I'm just going to kind of not zoom in so far. I'm just going to look at 15 there. We're given the function x cubed minus 2x squared. And on what interval is f of x concave down? Concavity. That just represents the second derivative. So I'm going to take the first derivative, 3x squared minus 4x. Let's take the second derivative, 6x minus 4. And we got to set this equal to 0 because we got to look for potential point of inflections. That looks like it's 4 is equal to 6x. And that's just 2 over 3 is equal to x. Okay? So we got to be obviously very, very proficient with our fractions. If not, you know, take your time with it. Try to simplify it the best as you can. So now we have a possible point of inflection from 2 over 3. So we're just going to test points to the right and left. So how about we test x is equal to 0 and then x is equal to 1. Easy enough. Do we plug that into the first derivative, the second derivative, or maybe to the original function? Which one will we plug it into if we're testing for concavity? Oh, the first derivative first. So remember, Drew, we're trying to find concavity, not what it's increasing or decreasing. So for concavity, we needed to plug it into the second derivative because that's where the second derivative defines concavity. So if you plug it into the second derivative, we're going to do f double prime of 0. That's going to be 6 times 0 minus 4. It's going to be negative 4. So we already know that that's going to be negative. It looks like that might be our solution, but I'm just going to double check. I mean, it doesn't take us long to plug in 1. 6 minus 4, that's 2. So that means that to the right of 2/3, we're going to have a positive concavity. So our interval, it looks like our answers have to be in interval notation. It's just going to be negative infinity to 2/3, which is going to be which is going to be option C. No, Drew's on here. Everyone here is collaborating. I love it. This is where we're going to make mistakes. If we're making mistakes, kind of like I do all the time, this is where we do them. During the test, that's where we don't do them. This is the opportunity to make mistakes. This is where we're goofy. This is where we just, can say whatever we think is the correct answer, and then we're all just going to be positive and help each other out. Okay, so let's go to number 16. Let me go ahead and kind of scroll up so we can see that right in the middle. So we have root x. If you guys can't see that, I'm just going to write it out a little better. Root x plus y squared is equal to xy plus 2. And what they want is dy over dx at the point 4, 0. Well, you already know dy over dx. We have a function with y's. We're going to go ahead and take the derivative, and we're going to use implicit differentiation. Here we go. So for the first one, the square root, we should definitely have somewhat memorized. It's going to be 1 over 2 root x plus 2y, but because I took the derivative of y, I need to include a dy over dx equals, now for the other side, I'm going to use the product rule for that xy. So I have x times the derivative of y, 1, dy dx, always include your dy dx, plus the derivative of x, which is 1 times y, and then the derivative of 2 is just 0. So what we have is 1 over 2 root x plus 2y dy dx is equal to x dy over dx plus y. Now, we can 100%, move everything to the other side so that we have dy dx's. In this case, just because we want to find the actual value, I'm just going to go ahead and plug in 4, 0 into my derivative that I have here. So I'm going to have 1 over 2 root 4 for the x plus 2, and then the y value is 0, dy dx equals 4, and then my dy dx plus my y value is 0. This is really nice because now what I get is 1 over 2 times square root of 4 is 2 plus, actually that entire thing just cancels out, so I don't even have to write anything, equals 4 dy over dx. And now all I have to do is divide the 4 to the other side. So I get 1 over 4 times 4 is equal to dy dx. If you simplify that, looking at your options, you're going to see that it is option B. Lucas, I go live every Tuesday, Thursday, and Friday around this time, but you could always catch the replays on my YouTube channel. This is being recorded right now, and I just posted on the YouTube channel for you guys to enjoy. All right, let's go to the next one, number 17. Ooh-wee. Okay. By the way, guys, the best way you're going to continue to get better at this, I know we're a week out, is just continue practicing as many problems as you can. And you're going to see that on test day, you're going to be like, fire, money, baby, I can do this. Because you're going to be able to recognize the certain types of problems that are given to you, maybe some certain tricks, but just continue practicing, okay? So let's see, we have the region R that's being bounded by y is equal to 2x and y is equal to x squared. And I believe if we were to graph it, my 2x goes like this, and then my x squared goes on the bottom. So my 2x is on top, my x squared is on the bottom. And we want to find the area. It's a little more complicated because what we have to do is we need to find where these points intersect because we need to find our parameters a and b. So we're going to do 2x is equal to x squared. We just set that equal to each other. Let's go ahead and move the 2x to the other side so that we have x squared minus 2x. We have a simple quadratic. Let's go ahead and use a GCF. Factor out the x from there, and you get x times x minus 2, and you get x is equal to 0, and then x is equal to 2. So that means that my parameters, my a value is 0, and my b value is going to be 2. And we're just going to do the integral from 0 to 2. Now we just have to be careful because we are doing sort of like a region here that's bounded by these curves. So it's always the top function, which is the 2x, minus the bottom function, which is x squared. And here's the thing, guys, if you make a mistake and if you accidentally did x squared minus 2x, you're just going to get a negative answer. So that just means that your answer was backwards. So Drew, off topic, yes, but it's okay. When you have L'Hopital, it's 0 over 0, infinity over infinity, and there's like 6 other ones. I believe there's 8 specific rules. To be honest, I always forget them. If you Google it real quick, like L'Hopital's conditions, you'll know. You'll be able to find them. All right, so let's continue. We're going to take the integral of this. This is going to be x squared minus x cubed over 3 from 0 to 2. Okay, when I plug in the 2, guys, I'm not going to make this mistake this time, chat. Last time I did that, and it was so embarrassing. So when I plug in the 2, that's 2 squared minus 2 cubed over 3. And then when you plug in the 0, luckily for us, everything turns into a 0, so I don't really have to worry about it. It's just a big fat 0. So then now you get 4 minus 8 over 3. Get your common denominators. So if I turn the 4 into a 4 over 1, that becomes 12 over 3 and minus 8 over 3. So your answer is going to be 4/3. And that answer is D. Haven't done videos on multivariable calculus yet, but that's the plan. Right now, I truly just want to make sure that we are covering AP calculus because there are some very, very lucky individuals that are going to take the AP exam in a few weeks. All right, let's continue to the next one, guys. Let's go to 18. There are 12 more problems on here, or I would say 11 because we're going to skip one of them because it has the wrong answer. Here we go. So a block of ice is in the shape of a cube and it uniformly maintaining its shape. The volume of the cube is given with the side length. V is equal to S cubed. And then at the moment that I'm just going to put when S is equal to 2, the volume is decreasing at a rate of 5 cubic inches. So I'm going to go ahead and put negative 5. Okay, let's go ahead and continue here. What is the rate of change of the side length when S is equal to 2. If you recall, this is a simple related rates problem. So we're going to go ahead and just take the derivative of both sides. So the derivative on the left is just dv dt is equal to 3s squared ds dt. And we want to find the rate of change of the sign length. So what we want to find is just ds dt. So we're going to go ahead and plug that in, or plug in the values that we do know. We know dv dt, that's -5, equals 3 times s squared, which is going to be 2 squared ds dt. And then so we have -5 is equal to 3 times 4, which is 12. -5 is equal to 12 ds dt. And then we're going to divide the 12 to the other side. Look at this. -5 over 12 is equal to ds dt. Look at the possible options. If you didn't write negative for your volume, you were going to get this answer incorrect. Okay? Because the correct answer is A, but if you didn't write -5 because the volume is decreasing, you were going to get that the answer was B. So it is not B, but it is A. So we got to be very careful with that. Christmas guy, I mean, I'm pumped for you. I am not a professor. I am just a content creator. I do private sessions, private tutoring sessions. I've been doing that for the past 13 years. And now I have a TikTok presence, and I am doing this as a job now. I have a couple brand deals. But if you guys ever want to support, I do have math books that I have for everyone to enjoy. So if you guys love what I do and want me to continue doing that, feel free to just check out all my resources. So for number 19, we're given the function g, which is so weird because the way it's written, it says f of x. Okay, what is the point of inflection of the graph of f? I think instead of g, they meant f. So we want to find the point of inflection for f. Well, here's the way we're going to do it. We have the original function, 3t minus 6t squared dt. And what do you know? If we take the derivative of this, it's going to be the derivative of the function on the right side, but it's an integral. So this is just going to be 3x minus 6x squared, according to the second fundamental theorem of calculus. That's the first derivative. We want the point of inflection, so we're going to go ahead and take the derivative again, and that's going to be 3 minus 12x. And we're going to go ahead and set that equal to 0, because that's where your potential point of inflections are going to be. I subtracted 3 to the other side, and I get 1/4 is equal to x when I divide the -12. So it looks like that's going to be our answer, but be very careful, because sometimes that's not necessarily a point of inflection. For this particular test, which resource is best to study from? Honestly, probably my YouTube videos or the TikToks that I have. If you want to continue improving your derivative skills, your integral skills, your area underneath the curves, I have a couple calculus books. But for the AP exam, I don't have anything specific, just these videos. Oh, green theorem, love it. Yeah, that's always fun. We can talk about that later on, after May 8th. So the answer is going to be 1/4. In this case, because there was no other options where there's no point of inflection, but you should always test whether or not this is going to be the case, okay? So if you were to do a number line, you will have to test points like x is equal to 0, perhaps x is equal to 1, and right away you can kind of see that your second derivative goes from positive to negative. So it switches sign, so it is a point of inflection. So we knew that was true. All right, guys, let's go to number 20. We got a few more problems and then we'll be done. How long have we been going for? Wow, 50 minutes. Awesome. I think we can maybe go a little further. Maybe at the end I can do some like integrals or something. We'll see. Okay, so all they're asking for here is to take the integral of this. So integral of sine of 3x dx. And you can almost do that in your head, but just keep in mind the idea is that you're doing u substitution. So du is equal to 3x. If you bring the 3 to the other side, you get that dx is equal to du over 3. So what you have is sine of u times du over 3. Okay? So you have 1/3 integral of sine of u du, and this is going to be -1/3 cosine of u plus c. But then because u was equal to 3x, you just plug that in. You could have easily done that in your head. I'm sure at this point you'll be very familiar with that type of problem and just know how to solve it. So typically for a free multiple choice question, you might not do a lot of work, kind of like I did there. It's funny that you're saying that. A book on series, I'm kind of coming up with something. And it's a lot of my books are like storytelling form, and I'm thinking of a huge storm that's just, at Sokotoa Park, which is the imaginary math land that I talk about. And there you're just gonna have all these leaves falling on the floor, and they're coming in different shapes and patterns, and you're gonna have to identify perhaps a pattern and the series, the sum of it. So that'd be kind of fun. Okay, so we solved that integral. Now we go to 21. This was the problem that we are gonna skip. And now we go to 22. So let's see, they give you the definite integral from 4 to 6 is 5, and then the definite integral from 10 to 4 is 8. Then what is the value from 6 to 10 of 4 minus 4 of f of x plus 10? Ugh, this is kind of nasty. I have taken the AP exam. I took the AB and the BC exam, and I got a 5 on both. Not really a big flex because that was really the only one where I got a 5. Everything else I did not do well on. Okay, so this is, again, a little interesting how they set this up, okay? So a couple things that I'm going to do. We know that I'm just going to do integral from 4 to 6 of f of x dx is equal to 5. And I know they told us the other one, that from 10 to 4 is equal to 8. But what I'm going to do is I'm going to switch it. 10 or 4 to 10 is equal to, and that's just the negative of it, because that's one of the properties of integrals, that when you change the parameters, when you switch them, it's just going to be a negative 8. Now, the reason why I'm doing that is because if I do integral from 0 to 10 of f of x dx, and I subtract integral from 4 to 6, I'm sorry. What this is the integral from 6 to 10. Let me know if you guys agree. So, okay. And again, the way I did this is, if you imagine you have a curve, this is from 4 to 10. This is the first area that they gave us. And then what I'm removing is the second area, which is from 4 to 6. So I'm removing this portion, so I really only have this portion. This is the one I want, and that's the integral from 6 to 10. So that's going to be really helpful, because now what we're going to have, if I continue to simplify this, we know some of the terms on the left side. Integral from 4 to 10 is going to be negative 8, minus integral from 4 to 6 is going to be 5, and that's the integral from 6 to 10 of f of x dx. And now we're going to have negative 13 is equal to the integral from 6 to 10 of f of x dx. Okay, that's going to be super helpful, because now what we have, now we can go ahead and integrate the one that they gave us up on top. We have the integral from 6 to 10 of 4 f of x plus 10 dx. So what we're going to do is we're going to go ahead and separate this a little bit. We're going to have two different integrals, plus integral from 6 to 10 of 10 dx. Math nerd, thank you. And now what we can do with that first integral, we can go ahead and remove the 4, so you can kind of see what we're looking at here. Ooh, and then we'll talk about that second integral in a second. It's just from 6 to 10 of 10 dx. Now, look at that integral from 6 to 10. That is the value that we have here. Pretty neat, huh? And so now what we have is we have 4 times negative 13, which I believe that's negative 52. We'll talk about that. But then that second integral, we're going to go ahead and integrate it using first fundamental theorem of calculus as 10x from 6 to 10. And so that becomes 100 minus 60, which is just 40. And then so now our answer is going to be negative 52 plus 40, and that's negative 12. So the answer is going to be A. This one was tricky, and I'm not surprised, because I believe as we get closer to the end of the test, we have about 8 more problems. It gets a little more difficult. Let's go ahead and erase this. Let's go to the next problem. So now we go to 23. Whoops. Okay, it looks like it's better. So what is the equation of the line tangent to the curve y is equal to 2x at x is equal to 1? Okay, equation of the line tangent, aka the tangent line. If you recall, the tangent line is y minus y1 is equal to m times x minus x1. So our x1, we already know, is just 1. That's what's given to us because we're saying that at x is equal to 1. So let's go ahead and find the y value at that point. So we're going to take the e to the 2x, and we're going to plug in 1 to that. So let me just go ahead and do 2 times 1, and that's just going to become e to the 2. Perfect. Okay, now we just need the m. Well, remember, m is the slope, aka the derivative. So m is slope. In other words, it's the derivative at x is equal to 1. So we're going to go ahead and take our function, y is equal to 2x. We're going to take the derivative, that's e to the 2x times 2, if you recall the chain rule there. And now we're going to just plug in 1. So e to the 2 times 1 times 2, that's 2 e to the 2. So now we have our x1, our y1, and we have our m. So if we have y minus y1 is equal to m times x minus x1, so we're going to have y minus e squared equals 2e squared times x minus 1. This is our solution. Now we just got to go to our pattern and see which one it is. So let's see. Looks like D. Easy enough. Easy enough. So immediately when they say equation of the tangent line, just make sure you do the y minus y1 m times x minus x1. At this point, I'm pretty sure that's going to be pretty clear. If it isn't, that's okay. Continue practicing, and you'll be just fine. Ooh, if Drew is still on here, they were talking about L'Hopital's rule. Check this one out. So they're asking for the limit as x approaches infinity. Let me write this a little bigger. The limit as x approaches infinity of 4 natural log of x plus 4 over 3x. Okay, the first thing that we're going to do is just use direct substitution. We're going to assume that we can do that for now. So we have 4 natural log of infinity plus 4 over 3 times infinity. If you notice, that's infinity over infinity. Let's go. Because now we can go ahead and use L'Hopital's rule. I'm sorry if it's kind of like if you can say it at the end, but it's just infinity over infinity. So now we're going to go ahead and implement L'Hopital's rule. And if you recall, that's just taking the derivative of the top and the derivative of the bottom separately. If I take care of the top first, that's just 4 times 1 over x, because the derivative of natural log is 1 over x, plus the derivative of 4, which is going to be 0, over the derivative of 3x, which is 3. And now we have 4 over, well, I guess we can do 4 times 1 over infinity. 4 times 1 over infinity over 3. Now 1 over infinity is 0, so we have 4 times 0 over 3, which just becomes 0. That's okay. It's okay to have 0. There's nothing wrong with that. There we go. All right, guys, let's go ahead and go to number 25. So we have the graph of the function above, and h of x is equal to, so again, this is f of x, and then they tell us what h of x is. And they want us to find h prime at 4. So the first thing we're going to do, since we have our function, x plus 1 f of x, we're going to go ahead and take the derivative, and we're going to use product rule. So the first times derivative of the second plus the derivative of the first, f of x. And now this is where we plug in 4. So we're going to have 4. And now we're going to have 4 plus 1 times, whoops. This is what happens when I change the colors. If that's helpful, or if that's if you guys don't care, let me know. But some people might want the color coding just to kind of understand where they're plugging in, or why I put the 4 there. So it's just so you guys can visualize it. I wanted to put, there you go. I wanted to put it in blue. All right, so let's talk about this. Whoops. There we go. So for the first parentheses, 4 plus 1, that's just 5. So we have 5 times f prime of 4. We got to be very careful here. F prime of 4 is the slope on the graph of 4. Now, luckily for us, and I'm sure they're always going to give you this, it's going to be a simple linear equation because we don't know the function, but we can find the slope there. If you look at the slope, there's another point down here that we can recognize, and we can see that the slope is down 2 over 1, so the slope is -2. So f prime of 4 is going to be -2. So we're going to go down below and put -2 for the f prime of 4 plus 1 times f of 4. Now f of 4 is just the y value at 4. And that's going to be right here. So f of 4 is equal to 4. So down below, I have f of 4. So negative 10 plus 4, and then the answer is negative 6. Booyah! A is our answer. Not bad, huh? Not bad at all. Okay. Math nerd, yes, they are correct. Mar, I do post the replays. As soon as I'm done here, I download this and I put it on YouTube for you guys to watch. And I have other YouTube videos. We did one, a free response question or free response questions yesterday. So that was kind of fun. All right, here we go. So number 26, let me scroll down a little bit so you guys can read it. So region R is the base where the function is greater, or f is greater than g, for all values of x between a and b. For this solid, each cross-section perpendicular to the x-axis are rectangles with a height 5 times the base. This is interesting. So what they're trying to get you to understand here is we have a region, and there's a function. We don't know how that function looks, but it kind of looks like this. Let's just imagine. Okay, f is on the top, and g is on the bottom. And this is from a to b. And they're talking about a cross-section. So immediately when you think those cross-sections, hopefully you think of like that volume thing. Where remember, there's a cross-section here. Maybe I can just immediately get rid of that red, and I can talk about there's a cross-section that's perpendicular to the x-axis. So this is the base. And if you recall, this cross-section is saying that it looks like a rectangle. So it's kind of like popping out the window or out of your screen. So this is my B, which is that solid line that I have on the bottom on the graph. And then the height is going to be 5 times the base. So the height is going to be 5b. So I believe they're talking about which of the following integrals gives the volume. So remember, volume is equal to the integral from a to b of the area of x dx. Now, in this case, the area is the area of the rectangle. How do you take the area of the rectangle? It's just going to be b times 5b. So b times 5b. In other words, this is going to be the integral from a to b of 5b squared dx. And the b is that region. So this is going to be, the b is my function f of x minus g of x. This is something that's very important for the FRQ, because I wouldn't be surprised if a problem like this shows up. So f of x minus g of x to the power of 0 is going to be our dx. Whoa, okay, hopefully you can almost see it. I know it's a little off to the screen, my bad. But anyway, if you're looking at these answers or these responses, it is going to be D. The 5 is just on the outside, even though mine was like to the right of the integral. We can move it out there. Awesome. All right, we got a few more problems, guys. We're going to finish this up, and then we'll be done for the day. So 27. Here we go. So they're telling you that the derivative already is x over y, which is great. And they're saying if y is equal to 4 when x is equal to 2, then what is the y value? So what they want here is they want you to actually integrate this using separation of variables. Nothing crazy, really. You're just going to multiply the y to the other side. And at the same time, we're going to multiply the dx, but I'll talk about that in a second. So y dy dx is equal to x. Multiply the dx to the other side. And we get y dy is equal to x dx. And the reason why we're doing that is because now we can go ahead and integrate. So this becomes y squared over 2 equals x squared over 2 plus c. Okay, easy enough. Now, before we even try to solve for a or for the y value, let's go ahead and plug in the conditions. Up here, they're telling you that when x is equal to 2, y is equal to 4. So we're going to go ahead and plug that into our equations that we have on the bottom. So we're going to have 4 squared over 2 equals 2 squared over 2 plus c. Let's simplify that a little further. So that's going to be on the left side 16 over 2. So 8 is equal to 2 plus c. So 6 is equal to c. So now what we have is this equation. I'll start drawing it or writing it in blue. Y squared over 2 equals x squared over 2 plus 6. And so now we're going to go ahead and isolate the y. So we're going to multiply everything by 2 so that we have y squared is equal to x squared plus 12. And then we can go ahead and take the square root of both sides to solve for our y. And y is equal to root x squared plus 12. That's our answer. That's going to be D. I don't even know if a problem like this could even be on the multiple choice. It's a little too long, but I mean, they're expecting that you're kind of struggling at the end. So maybe they're going to give you some stuff like that. Okay, so let's go ahead and erase our work here. Let's go to 28. Almost done, everyone. So we have the function f of x, and we have x squared plus 1 over 3x, so they just want the derivative. Quotient rule, or, yeah, let's use quotient rule here, just because it looks like maybe that's how they want the answer. So it's going to be low times the derivative of the high, so 2x, minus high d low, which is just 3, all over 3x to the power of 2. Okay, our answer obviously doesn't look like that, so we're going to have to simplify it. So we got 6x squared minus, this is where you have to be very careful, because when you distribute the 3, at the same time, perhaps I can even distribute the negative if I wanted to. Or maybe not, I'll do that in the next step, because that's going to be 3x squared plus 3. But this is why you have to make sure you put that parentheses, because it's important, because now I'm going to go ahead and distribute the negative to both of these terms. And then now we have minus 3x squared minus 3 all over, let's simplify this a little more, 9x squared on the bottom. So we have 3x squared minus 3 all over 9x squared. That's our solution. We could totally simplify it if you wanted to, but notice that none of those answers are simplified form, and that answer is B. Easy, yes, I 100% agree. One of the easiest ones, I would say. All right, let's continue. We got number 29. Number 29. Okay, let me know if you got low D high minus high D low over low low. Yes, typically that's how I memorized it. Actually, no, I lied. I memorized it by like the bottom equation times derivative of the top equation minus the top, all that stuff. But someone in high school, a student that or a few students I see in privately, they know, or they recognize it as low D high minus high D low over low low. I think it's helpful. Okay, for 29, we're going to go ahead and solve for the integral here. And hopefully you can recognize that this is just a simple u substitution problem. Now, you can totally do this in your head, but I'm just going to show the work. So you make u equal to x squared plus 3x. du is 2x plus 3 dx. And if we divide the 2x plus 3 to the other side, you're going to get that du over 2x plus 3 is equal to dx. And all that does for you is when we write the integral, we get integral 2x plus 3 times u to the power of 4 times du over 2x plus 3. No surprise there, because the 2x plus 3's cancel out. Again, I'm sure a lot of people already know the answer to this, but I just want to show the steps. So we have u to the 4th du, which is u to the 5th over 5 plus c. And don't forget, our u value was 2x plus 3. So our answer is be 2x plus 3 to the power of 5 all over 5 plus c. So if you look at this, let me know in the chat which answer it is going to be. Is it going to be A or D? Had to grab a LaCroix real quick. Guava, baby. So it's going to be A. Because for the A value, or for the A option, we have 1/5 as our fraction, and that's the denominator. Paige, nice. Okay, cool. That was 29. Our last problem, unless you guys want me to do some integrals. Well, after this, I'll take like a 1 or 2 minute break. So let's go to number 30. So we have two differential functions, f and g, and they have the property where f is greater than g. Let me scroll this down a little bit so y'all can see it. Okay, and it's bounded by the region 1 and 2. Select the values of f or g in the tables below. Estimate the area between the curves f and g between 1 and 7 using the right Riemann sum. Yo, oh, that's crazy. That is crazy. How in the world? I mean, during the multiple choice question, that's kind of insane. But anyway, luckily for us, just imagine. They even tell you in the very beginning that f is greater than g. So you have your function f and you have your function g. We don't know where it's at, but we know that they intersect from 1 to 7 or something like that. Or they might not even. Yeah, it doesn't look like it. It does. However, what they want is they want the integral from 1 to 7 of f of x minus g of x dx. And they want you to use Riemann sums. So the way we're going to do this is we're just going to split this up into two different integrals. Okay, we're going to start with the f. So the steps for that, if we're just focused on the f, let me highlight that or circle that in blue. Let me actually highlight it so y'all know what we're working with. Okay, if you recall the way f looks, okay, we're doing a, what do they say, a right Riemann sum, okay? So we're going to take the first interval, which is 1 to 4. So the distance between that is going to be 4 minus 1, so it's going to be 3, times the y value, and it's a right Riemann sum, so we're going to start with the 5, plus, and now we're going to go to the next interval, which is 4 to 6. So it's going to be 6 minus 4 times the right value, which is 2, plus the next interval, which is going to be from 6 to 7. Okay, for some reason stuff won't erase on mine. But anyway, we're going to do 7 minus 6 and then times the y value. Okay, so that's going to be for the f. Let's do the g. I'm going to do it in blue. So it's the same idea, but now we're just using g. So for the first interval, 4 minus 1 times the right value of the function, that's going to be 1, plus 6 minus 4 times the right value, which is going to be 0, plus 7 minus 6 times the right value, which is going to be 5. We just have to simplify this and add all these together. Lucas is calling B. I don't know what the answer is, but we're going to find out. Okay, so for the first one, maybe I can, I'll move all my work kind of on top here. Okay, so for the first one, I get 4 minus 1, so I get 3 times 5 plus 2 times 2 plus 1 times 8. Oh, it's kind of off to the side there. So it's going to be 15 plus 4 plus 8, and that's going to be 27. If I did that wrong, please correct me, but I think that's going to be correct. And then now we go to the next one. 4 times 1 is going to be, so 4 times 1, or not 4 times 1, 3, plus, and then this next one cancels out. And then now we just get plus the next value, 7 minus 6 times 5, and that's going to be 1. So then our answer should be 27 minus, oh, we're not adding these, we're subtracting them because it's f minus g. Minus, let me do it in blue. Oops. So 27 minus, and then we're going to subtract the value that we found for g, so minus 4. And then that's going to be 23, which is the incorrect answer. Oh my goodness. Oh my goodness. Let me just double check if I did any of my work incorrect. 6 minus 4 is 2, 7 minus 6 is 8, and then 4 minus 1 is 1, 4 minus 6. And Ali, someone said, yes, I would do 3 plus 5. Thank you. Paige, you're on it. Thank you. Okay, that's the second mistake today in an hour and 13 minutes, so I'll take it. Ali, I'll go over the Riemann sums in a second. So instead of 3 plus 1, it should have been 3 plus 5, I believe. Yes, so then that sum would have been 8. So if I erase my work here, our sum is going to be 27 minus 8, and that's going to be 19. There we go, B. Who guessed B? Paige said B, and then someone else, yes, thank you, Manu. Yes, everyone calling out. And Lucas said B. Wow, both of you, W's, let's go. Awesome. Okay, so that's the entire multiple choice questions that I wanted to do. I'm going to stop sharing this real quick. But Ali said if I can review, whoops, don't mind me. Ali asked if we can review, what did you ask? Types of Riemann sums. Okay, we're going to talk about the Riemann sums in a second. Let me just go ahead and open up a page real quick. If you all want to take a little break, take your phone with you. Manu, yes, it was 3 plus 5. We corrected that at the end, thankfully. Okay. It's actually not what I'm... Oh, this might work. Okay, this won't work. I'm working on a new... So I'm actually doing TikTok live with this program. I'm not used to this. So I think I'm going to open it up with a different program. Give me 1 second. So we're just going to review. Before we finish off, we're going to talk about the different types of Riemann sums. The ones that I know that they give you, they don't necessarily give you midpoints. They give you right, left, and then they can ask you for the trapezoid rule. So that's the one that we definitely want to review. So just give me 1 second. I'm going to open this up with the program that I want. Hopefully it works. Let's see. Trying to do, give me 1 second. I'm trying to get this program file to open up. Otherwise, we're going to try something else. Bro, let's see. I'm trying to open up my Blackboard so that you guys can actually see what's on the screen. Ah, here we go. Here we go. We got it. I think we're getting it. Oh, if I wasn't on TikTok Live Studio, this would be so much easier. Okay, I think this might work. Here we go. All right, guys, again, just take a quick break. We're just going to review the basic techniques for right, left, and then trapezoid rule. Oh, this is what I want. Maybe not. You know what, screw it. We're just going to do this. For the basics of calculus, continue practicing as much as you can. That's honestly like my biggest suggestion. I don't know what calculus class you're taking, but you know, picking up a book and just like solving some of the problems will always be good. Okay, I'm gonna fix this next time. I don't know what's going on, but could we do this? I'm trying to change the shape. Okay, give me 1 second. Let's just try this out. This whiteboard just isn't working for me. I'm not used to the TikTok live thing, so I'm just gonna try it out. Otherwise, we're kind of at an impasse, you know? It's kind of annoying. Anyway, what's everyone up to right now? What's everyone got going on in the weekend besides studying for this exam? Typically, they don't ask for the midpoint. I hardly have seen it, but I'll talk about an example like that. Okay? Bro, like, it's so sensitive. Oh, I hate this. I hate this. You know what? We're just going to do this. You're going to see in a second. Okay, like, Paint just doesn't want to work, which is kind of frustrating. Okay, we're just going to do this. We're going to run with it. You're going to see what I'm doing. Okay, so forget that little box there. I'll fix that later on. I don't know why that's happening. But for now, we're just going to talk about right, left, and trapezoid rule. Okay, so let's just say, for example, that we have some x values, and then we have the f of x values. Okay, let's go ahead and do like 1. Let's do 3. Let's do 4. And then immediately I'm just going to do 10. So the reason why I don't want them to be in order is because typically they don't give them to you like that. And they want you to do right or left Riemann sums depending on what the functions are. But they're not going to be even subintervals. So let's just make this like 10. Let's make this 8. Let's make this 1. And let's make this 5. I'll look at that FRQ in a second, okay? We're going to do the left and Riemann sums. So if Ali, if you're still on here, the idea here, if you were to graph this, okay, you have some points. 1, 2, 3, 4 is here, 5, 6, 7, 8, 9, 10. So you have 10 up here. So let me just kind of draw everything out. 6, 7, 8, 9. There you go. Okay, and then you're given y values. They don't have to be perfect, but I'm just going to kind of draw them. This is the first point. Then the second point at 3 is going to be like a little bit below. Then that one at 1 is going to be down here. And then the one at 10 is going to be like up here. Okay, maybe that wasn't the best option for 10, but we're just going to keep it that way. So if they want the right or the left Riemann sum, you need to imagine that you're trying to take, because these are the only intervals we have, let's just imagine like this is our function, however it looks. Because this is the only picture we have, or the only intervals we have, the first one, if we're taking the left Riemann sum, you're going to draw your triangle, or your rectangle, I'm sorry, and the height has to be the left value of that. So the idea is that if you're doing the left Riemann sum, so LRAM, that's what they call it. My iPad is acting up there. So if they're taking the LRAM, is what you call it, okay, you're going to take the width of this rectangle, which is going to be 2, because it's just a difference between 1 and 3, times the height, which is going to be the left portion of it. That's why it's going to be 10. It's going to be the left y value. Plus, now you go to the next rectangle. So now you're focused on the rectangle between 3 and 4. So if you're looking at 3 and 4, you're drawing your rectangle. You're going to draw your rectangle. Wow, my iPad is just acting up today. And remember, the height has to be the left y value. So the width here is still just 1 times the height of the left endpoint. And that's going to be 8, looking at the table. Plus, and then you do the same thing from 4 to 10. So if you think about it, again, we want to find this rectangle here. So from 4 to 10, the width is going to be 4 to 10, which is going to be 6, and then times the height, which is going to be 1. And so if you simplify this, that's 20 plus 8 plus 6. You just simplify all that, 28, that's going to be 34. Now, if you were to do the right sum, so RRAM, it will be essentially the same thing, but let me just go ahead and erase this real quick. So you're still finding the same rectangle, but remember, the height now has to be the right side of it. So it's going to kind of go like this. I have to draw my points again because my iPad just doesn't want to cooperate with me today. So it's up here. 4 was right here, and then 10 is up here, for example. It's actually a little higher. My function was way off, so it's like up here. But this is just an estimate, obviously. Okay, so again, if I was to take the right sum, now what we're going to do for the first rectangle, you still have the same width, which is 2, but now the height is going to be the right side of the function. So you still have a base of 2, but then now your height is going to be 8, because that's the y value for the right value. And so you draw your next rectangle. So your width is going to be 1, and then your height is going to be the right value. So it's just going to be times 1 plus. And if you were to just not even look at the rectangle anymore or try to draw it out, you can look at the next interval, which is from 4 to 10. The width is going to be the distance between 4 and 10, which is 6, times the right value, or the right y value, which is going to be 5. And then you just go ahead and simplify that. Paige, I believe what's going to be on there, if anything, in terms of arc sine, arc tangent, maybe a multiple choice question. So I would get kind of familiar. Nothing crazy. It's going to be something pretty standard that you can solve. If you see like an arctan, or if you see in a multiple choice question that it is going to be arctan or arcsine or arccosine, if you know the derivatives, take the derivative of each function and see which one matches your equation. That's my best suggestion. Otherwise, continue practicing those arc trig functions. Okay, now here's the thing. If Ali's still on here, now we're going to talk about trapezoid rule. Trapezoid rule, I highly suggest, since because we're so close to taking the test now, one of the things that I will suggest, if we're going to do trap rule, okay, we are going to use this equation. It's b over a minus 2n times f of x0 plus 2 times f of x1 plus 2 times f of x2 all the way to the n. And if it's just, well, actually I can do, instead of f of x0, I'm going to do f of a, and then at the end it's going to be f of b. Now look at the type of equation here. This is for trap rule. The first one is b minus a over 2n. That's going to be huge. So b minus a, those are your parameters, over 2n, that's the number of rectangles. And then f of a is just the first y value. And then everything else after that, you just add up every y value, but then notice that there's a 2 in there. And you continue adding those up until you get to the very end, and you don't multiply that by 2. It's just going to be f of b. This equation, I would even take a screenshot, try to practice that. There's a possibility that they give you an equation with even subintervals, and they're going to ask you to do the trapezoid rule. Yes, They have to be equal, and that's what I just mentioned. So for example, for this table, it's not going to work. They have to be equal. So let me go ahead and erase and let me give you an example of that. So let's just say, for example, I have, these are my x values. This is f of x. So we're going to have 1, and then 3, and then 5, 7, and then 9. And this is going to be like 10, and then 2, 1, and this is 5, and then this is 4. Okay? So if we do this, again, our intervals, if you look at the intervals here, we have one interval from 3 to 5, that's interval 2, from 5 to 7, that's interval 3, and then from 7 to 9, that's interval 4. So our n is going to be 4, our a is 1, and our b is 9. Those are the endpoints. So if we're using trap rule, we're going to do b minus a, so 9 minus 1 over 2 times the number of subintervals here, so it's 4, times, and now we just go with the very first term, f of 1. That's the first y value. So that's just 10, plus 2 times the next term, which is 2, plus 2 times the next term, which is 1, plus 2 times the next term, which is 5. And then at the very end, we don't multiply it by 2, and that's just going to be 4. And you just simplify that. Okay, pretty cool. I don't know, V, if you're still on here, we can look at 2018. Is it the Calc AB or the Calc BC? That will be our last problem. If you're on here, let me know. Let me know if you're still on here, and then we can definitely look over that one particular problem, okay? If you're still on here, hello, the Reed kid, LOL. Okay, I don't know if he's on here anymore. Okay. Anyway, so this was the last thing that I wanted to review. Hopefully you guys got some value out of it. Don't forget, oh, never mind, he's still on here. He's still on here. He wants to do one more problem. So I'm assuming AP Calc, so 2018 FRQ. What number was it again? Can you let me know in the chat real quick so I can pull it up? Okay. Let's go ahead and see what value that is, and I'll pull it up real quick, okay? It was part 1, but don't understand B. So was that, I'm assuming, question 1, part B? Okay. Let me go ahead and pull that up. That way you guys can all see it. Give me 1 second. I'm actually going to open it up here. I'm going to close this. Gotta love technology. You gotta love technology. Let me go ahead and close this. And again, let me know if that was problem 1, section C. I'm going to go ahead and open it up. Don't save. Okay, cool. I just need to open this up real quick. Give me 1 second, okay? I'm going to get it from my email. Yo, TikTok Live drains your computer. It's kind of frustrating. Okay. Give me 1 second. I'm trying to open this up. Okay. I am in. I'm just going to open up that one file for you. And again, guys, this will be our last problem, but you can always get all the replays on YouTube where I post them right after this. Okay, I'm just trying to get the file here. I had to email it to myself so that I can do it. Give me 1 second. I'm uploading. So V specifically asks if we can do the FRQ from the first section, part C. This is 2018, part C, or section 1, and then part C. Okay, I'm opening up the doc, and I think we should be good. I'm just closing this. All right, here we go. It's just loading real quick. Okay, this is supposedly the file, but for whatever reason, still doesn't want to open. Give me 1 second. This should 100% be faster. This is insane. I'm so sorry, guys. It just drains my memory for whatever reason. My computer is just lagging on here. Okay, so this was the first section. Let me know if this was the correct one. So they particularly asked, with this question, they don't understand part C. Okay. There you go. And I kind of much better. Hopefully you guys can see that. Oh, geez, come on. So sensitive today. Okay, so they give us that the rate at which people enter the line at an escalator at this specific rate. So they have the rate between 0 and 300, and then the rate after that is going to be the rate after time 300. The rate is going to be 0. And then they also mentioned, so in the very beginning, there's going to be 20 people in line. How many people enter the line in the escalator? Okay, so A is just going to be the integral. Part B, during the time, there are always people in line for the escalator. How many people are in line at time is equal to 300? So we just have to find the amount of people. And then they talk about people exiting the line. Okay, so let me just kind of write the info that we have. So sometimes you need the information from part A. So I'm just going to put enter is going to be this specific rate, and then leave or exit the enter. So I'm just going to put E is for enter, leave is going to be for the exit. So that's going to be 0.7. And now they want for what time are there no people in line at the escalator? So I believe what they're saying, you had to find out how many people are in line at time is equal to 300. So we had to find that first. So first we had to do 0 to 300 of R of 5, or R of t, I'm sorry. So this is the amount of people that enter the escalator minus 0 to 300 of 0.7. And then you had to add how many people were there in the very beginning. It's going to be plus 20. So you have to plug that entire value into your calculator. So I have to go ahead and do that. Math 9. So this is why I don't like doing the calculator portion here on TikTok, just because it sometimes takes too much time. And then again, people can't see me type my stuff. Okay, 1 minus x over 300. And then this is whole thing to the 7th power. Okay, so dx minus, and then I have to take the integral 0 to 300. 0.7, and then that's dx, and then plus 20. Okay, so I got that there's a total of 80 people after time is equal to 300. Okay, and after that, no one else enters. Okay, so now we need to find at what time. We already know that there's 80 people. So this is part C. Part C is asking at what time after time is equal to 300, when is there going to be no people? So what we're trying to find is we're doing 80 because that's how many people are present in the escalator at time 300. And then we're just going to find, well, they continue to decrease at this rate, 0.7 t. And we need to find out when that's going to be 0. Why is it 0.7 t? Because that's the rate at which people are leaving at a specific time. So all we need to do is just find or solve for the value of t. So negative 0.7 t is equal to negative 80. And now we just go ahead and divide this value. And I get that t is approximately 114.28. So we could do 285. So that's how long it's going to take after time is equal to 300. Let me just erase this. Time is equal to 114.285. So again, that's how long it takes for all the people after time 300 to leave. So that means that time was equal to 300. That's when we started. If we add that 114.285, that's going to be 414.285. So after 400 and I guess after time 415 is when people leave. I'm not sure if that was the answer. But the idea there was you just have to kind of understand after time 300, there's 80 people in the escalator, and we just want to know how long it's going to take for everyone to be off the escalator. So we need to do 80 minus 0.7 t, and we need to find out when that value of t was going to be. So Paige, let me just read that. How do you word your answer for this W measurement in units? If they're recalling, so for example, so for like number one, how many people are there? So we're going to say, you know, whatever we find for part A. I didn't figure that out, but you're going to say, you know, X amount of people. Yes, plus 300. And then so for part B, if they ask during the time, how many people are online at time is equal to 300, it's just going to be people. And then for part C, after what time, I believe this one doesn't say, it says seconds. So we're going to say that time is equal to 415 seconds. So hopefully that helps, Paige, because you said for this W answer. So for this one, we would just say, yeah, we need to write the measurement. So it'll be 415 seconds. Hopefully you guys can see that kind of on the screen. And yes, you're welcome. I will post this on my YouTube. As soon as this is done, it's going to be loaded, and hopefully I can already post it on YouTube for everyone to watch, okay? Anyway, guys, that is going to do it for today. Don't forget that I am going to be back on Tuesday, on Thursday, and then Friday again as we prep for that AP exam. Hopefully you guys continue to review as many problems as you can. The best way to continue to improve on this is just through practice. I wish you guys the best. I hope you guys are studying really hard this week. I know a lot of people might have other AP exams, but this is when you should be studying. And then next week, you kind of start tapering. All right, y'all. Before I leave for part C, would you have to round? I would say yes. You perhaps, you know what? They didn't say. So perhaps you don't, you can say 414.285 seconds, or you can round it. I think that's going to be fine. But of course, we don't have, well, technically we do have half seconds and all, but I will go with the whole answer. All right, y'all. Again, hope you have a fantastic weekend. I will see you all next week. Take it easy. Bye now.